I'm very pleased to have Richard Zach with us, who is passionate about Linux, Rust, and has been contributing to the open source projects. Previously, he has worked with Profion to develop Enarx, and he's going to explain to us how this all works. And a special thanks to him, he has come all the way from the US just for this tutorial. So, give him big hands. Thank you.
Hello there, good afternoon. My apologies for being a few minutes late. All right, so my name is Richard Zach, current maintainer of Enarx since Profion kind of closed up, fortunately. So I'd like to talk a little bit about what is Enarx, the ecosystem, and our unique approach to attestation. And I'll talk about some of the workflow and kind of pros and cons, at least as I see them. So what is Enarx? So Enarx is an application, it's an open source written in Rust, and it essentially just runs your WebAssembly binaries in a trusted execution environment. So at the moment, we support AMD's SEV SMP, so not just plain SEV, Intel SGX2 or the EVMN dynamic memory components. Enarx is modular, and in the future, I would love to have support for ARM CCA, for example. So I'd like to talk to people and maybe get some hardware if it exists. One of the neat things about Enarx is that it has a very small TCB. So when you run your WebAssembly binary, the only thing that's in the TEE with your binary is Enarx, which includes Wasmtime, which is our runtime environment for WebAssembly. And I guess as we learned yesterday, there's some controversy about some firmware with SMP, so I suppose that's in there too. But otherwise, it's pretty small. And we wanted to make sure that the majority of what you're running is your code, not other people's stuff. And of course, you can run it on Windows or Mac or other platforms just as a test environment, but of course without protections. So what is WebAssembly? WebAssembly is a virtual instruction set architecture where various programming languages can compile their binary and it can be run somewhere. And my favorite thing about WebAssembly is that I feel like it beats Java at its own game in terms of write once, run anywhere. So any programming language can compile to WebAssembly, and then any WebAssembly runtime can then go run your WebAssembly binary, of which Enarx is just one of these runtimes. And it doesn't matter whether it's SGX or SMP, so you get some vendor agnostic attributes there. So if for some reason you wanted to switch from AMD to Intel, you can use your existing binary, no recompilation, no refactoring, no changes required. And the same binary, of course, would work between ARM or x86 or RISC-V. A nice thing too is security. WebAssembly cannot do anything weird without your knowledge. So WebAssembly cannot read or write files. It cannot open ports and receive connections and make outgoing connections unless it is explicitly permitted to do so. So Enarx would have to open up a port or open up a file handle and then pass that file handle information to the WebAssembly runtime. So there's no way if you're running a WebAssembly binary that you'd have to worry about, is it going to call home? You couldn't have WebAssembly ransomware because it can't open your files that you didn't already tell it could do so. But more importantly, more relevant to Enarx is that confidential computing provides data privacy. Provides data privacy, and Enarx in this case is the application. And so by compiling your program to WebAssembly, you're moving your program from application to data. So therefore you effectively get data privacy as well as in addition to the application privacy. So one of the components in our ecosystem is Steward. So Steward is a confidential computing aware certificate authority. It's written in Rust. It was initially going to be kind of like a proprietary thing of Profian. But when Profian closed, it was donated to the Linux Foundation and is part of the Enarx project, and was relicensed as Apache 2. So essentially what Steward does is it receives a certificate signing request from Enarx, and it essentially just goes through and does all the checks, which I'll talk more about that in a moment. And then it returns back a signed certificate if all of the checks pass. This too is modular, so it can be expanded to be able to do attestation for TDX or ARM or RISC-V or something else. And it doesn't require Enarx itself, so it's a standalone application. And it is stateless. So the only thing Enarx has is the root certificates for the vendors, and it doesn't have to keep track of any internal state. So we did this as we kind of envisioned that we could have kind of like a load balancing situation, and it wouldn't matter which which steward you talk to. So we have another component called the drawbridge. This too is going to be a proprietary component of Profian and was also donated to the Linux Foundation, relicensed as Apache 2. Like Steward, the idea is that it would be compiled also for WebAssembly so that we can have these components also running in a confidential computing environment. And the idea here is that your workload, or rather your instance of Enarx would attest to a steward. Its certificate would get signed. And then now, only by using the HTTP authentication with your steward signed certificate, then would drawbridge release the workload. What's nice here is that in this case, your workload actually never existed on disk. So you also get more application privacy. The workload data is stored as a Merkle tree. So when you upload all the data, it computes all the hashes to make sure everything's appropriate. And then it uses OpenID to make sure that you don't have to have yet another silo where you keep track of user accounts. It can be configured to talk to some OpenID provider to hopefully make life a little bit easier. So we talked a lot about attestation, and so I wanted to talk a bit about like what is this process. So there's a lot of data to be looked at, and I think this is certainly a place where formal methods could help to make sure that that nothing is overlooked. So what Steward receives in the certificate is just the opaque binary blob from the CPU. So Enarx isn't doing any parsing of the data. It literally just takes it and puts it into the extension. And Steward has the logic to go through and for AMD or for Intel to unpack that binary blob and check all the fields. But that's just the attestation report from the CPU. So in addition to that, we check a couple of extra things. One is we require that Enarx keeps an updated certificate revocation list from the vendor, and then that is included with the certificate signing request. Now for AMD, the public certificate is not included in the attestation report. So on an AMD system, that certificate is added, the public certificate is added to the certificate extension. And for Intel, we also require the full TCB report, which Enarx can pull directly from Intel's APIs. So all this data is in this extension as an array of bytes. Steward knows how to unpack all of this. So then it starts actually doing the checks. And it wants to make sure, does the signature of the report match the CPU's private key? I'm sorry, does the public key of the CPU match the certificate, the signature of the report? And the CPU's key, the CPU certificate, is that part of the vendor's certificate chain? So the Steward has the vendor certificate, the root certificate, and it just checks to make sure that everything was signed appropriately. We also make sure that the certificate revocation list was signed by the vendor's certificate authority and that the CPU certificate hasn't been revoked for whatever reason. In addition to that, we have a couple of optional flags that can be set. So we can say that a certain firmware version could be required, or that you have to be running a certain version of Enarx. Or perhaps that Enarx has to be signed by a certain key. And that's to make sure that somebody hasn't recompiled Enarx and then did something weird with how the attestation data was sent, so that if we were to run a public steward, we could be absolutely certain that the code that the person is using with Steward is exactly what we expect. And the response is simple. Either there's an HTTP error or there's a signed certificate, which Enarx can then use. Now, from attending the talks today and yesterday, I've learned a lot about how there's been a lot more going on in the industry with different approaches to attestation. I think probably Profian, well, we started working on this over 2 years ago, so I don't know what the state was 2 years ago, but that's probably why Profian decided to kind of pave their own way for this. On the AMD side, there's a couple of other things that we check. We check the policy flags to make sure that there isn't a way that the guest VM could be migrated to another machine. And then for both cases, we want to make sure that any debug flag that is set in the CPU or for the TEE is only permitted if Steward itself is running in a debug mode. Of course, any unused parts of the report we check to make sure are zeroed. Intel is a little bit different. The Intel TCB report has all kinds of further information about different components of the CPU. And most importantly, to check to see, is the CPU's firmware up to date? Or if not, are there any advisories? We also check to make sure that the FMS PC from the TCB report, first of all, the TCB report has to be signed by Intel, that the FMS PC matches the public key to make sure that along the way, we've checked to make sure that we're getting the TCB report that matches the CPU, that it's up to date, and that Intel signed it to make sure there wasn't any opportunity for any kind of fraudulent data. And all these things have to pass. So this here is an example configuration of what this might look like. So the signer is the key, but of course there's different hash types, so the hashing looks different. We can see that for Intel that we might decide that maybe the firmware is out of date, but we have some advisories that maybe we don't care about. So our workflow kind of looks like this. The user or the administrator decides that you want to deploy a workload on Drawbridge, from Drawbridge with Enarx. And so Enarx goes to contact the Drawbridge, and Drawbridge says, no, you need to go attest to my steward. And when you deploy based on, it looks kind of like GitHub, right? Where you've got the repository / project, and then you could do an @ and then the hash. And Enarx at this point remembers the hash for use later on. It then spins up an empty keep. A keep is just what we call a trusted execution environment. So at this point, the keep is up and running with Enarx loaded in memory, but there's no workload yet. And so that is the hash that we take for the hash fields on both the SGX and the SMP side. So that's just Enarx loaded in memory. Enarx then asks the CPU for the attestation report, and we also provide at that time what is the workload that we're expecting. And then the CSR is generated, and that goes off to the steward. Steward does all of the validation, as mentioned previously, to make sure that everything is correct. And if that is the case, then it responds back to the signed certificate. So Enarx then goes to the Drawbridge, now being able to do HTTP client authentication, and Drawbridge is able to respond back with the WebAssembly binary and any special configuration that might be required. And all the drawbridge really has to do is make sure that the Enarx certificate is in the steward's PKI chain. And then when Enarx receives the binary, it does a check again to make sure that the binary that it received from Enarx, from the drawbridge, was the binary that the user asked for. And if that all works, then the application is running, and it uses then the steward signed certificate for all of its TLS network communication. So now when any other third party, they just have to trust the steward, and you don't have to kind of have the attestation process again. So I don't know how well, oh, okay, I feel like this doesn't look too terrible. I was afraid when I was making the slides that maybe this wouldn't show up too well. But I tried making a chart here that kind of shows the workflow. Thing that's kind of added is in the top here. We can say that there's the configuration that administrator would have to do to kind of get the software up and running on the machine so that you can either launch TDD. But then at the bottom, anytime the workload goes and communicates out, it is using the steward provided certificate. So some pros, at least as far as from what I was thinking, this way you can just use your existing TLS software. You don't have to have relying parties or third parties that have to be aware of changes to the TLS protocol. Another thing also what Steward does, I'm sorry, what Enarx does is that the way we designed it is that by default, the WebAssembly binary would just do plain TCP communications, and Enarx itself would wrap those communications with TLS. And we did that so that A, it's easy to make sure that the WebAssembly binary is using the steward provided certificate. And two, we want to minimize ideally or eradicate having to do cryptographic operations in WebAssembly. So that this way, the part of Enarx that's inside of the trusted execution environment is doing the TLS communication. So no special protocols required, no change in configurations. You don't have to worry about what data you're being sent around. However, the other thing too that we were thinking about was no private information about the hardware is leaked. So we spent a lot of time at Profian thinking about, well, how or why did someone trust the steward? And the best that we came up with is if you're setting up an environment, you've got some confidential workloads, you probably have your own steward, and so it's not that far off to say, well, I'm going to trust my steward. But if that's not necessarily the case, we didn't want to have a situation where we're saying, okay, this workload is running on some SGX machine, and this is the hash of the key. We wanted to make sure that there was some hardware privacy. But then once you have the certificate, it can be used anywhere. So if you want to go and authenticate to a key server to get some private keys, you can do so easily because that key server would also know about the steward certificate or get whatever other further credentials or cryptographic material that you might need. Now, I suppose there are some drawbacks to this too. Our approach requires that you have to trust the steward's root certificate. So maybe that's not a problem. Maybe you have full control over your environment. But a lot of systems, you have to go through extra hoops to add a new certificate authority to that system software. And some people may have privacy concerns about adding some new certificate authority. And then the other part of it too is, okay, so let's say you're using some steward and steward is issuing some certificate. Well, what configuration did that steward allow for? What version? Was it strict and you could only use certain versions of Enarx? Or did it allow literally anybody to recompile Enarx themselves and just use that version? Maybe the steward allowed some Intel advisory that you're not okay with, and that information at the moment is not present. But I did like one of the talks earlier, talking about what does the CSR attestation or attestation in general do for the whole PKI chain. So maybe there's a way that that could be kind of improved. But yeah, ultimately there's a couple of choices that the steward configuration person could make, and maybe that's not appealing to everybody. And that's what I have for today. I want to thank the folks who founded Profium and made Enarx a thing, and I learned a lot from the whole experience. It was brief, it was about a year. And thank you all for having me. And I feel like I went a bit quick, so I would like to mention that, you know, Profium may have closed up shop, but we still have plans for Enarx. Enarx isn't dead, it's not going anywhere. We want to create our own kind of demo kind of steward, so kind of give people an environment to play with, to try it out. You know, set up a real certificate authority perhaps with an HSM, which means I got to figure out how do I connect an HSM to Steward, which I don't know how to do that. And then we have some policy kind of ideas for what we can do with Enarx to kind of add flexibility while still not making it too easy to just do whatever you want. So, and with that, if there's any questions, I hopefully can answer them.
So any questions? Oh, it's not good. No.
So, Hans before was presenting this attested CSR thing, which an obvious question would be, would you be interested in like that? Is there an incentive for you to?
Sure. Yes. And I mean, I'll be honest. I mean, the incentive for me is I want people to use this, and so I feel like it needs to fit into the broader kind of ecosystem. So, absolutely. At the moment, it's just me, so development may not be so fast, but yes, absolutely. But yeah, no, and perhaps, I don't know what the state of the project was when we got started, but maybe we would have gone that way earlier. I don't know, I didn't make the decision for all of this, but yeah, absolutely. I guess one question though that I was kind of thinking about is with some of the other approaches, you know, how do you know necessarily that all of the fields were validated, and you know what fields need to be validated, and you know, do you and I care about the same validation fields? I feel like, you know, there's a lot more that maybe need to be discussed about, you know, doing attestation. I feel like it's a big thing that maybe was glossed over, but maybe that's a separate discussion.
Yeah, I hear you. This is a question of ability from the test or whoever drives the process to select the backend verifier that sits behind the CA.
I see.
And which policies to use them for using them to the sits behind. That's a very good question. I think well, I don't remember exactly the detail of the files that I'm writing up, but there are some verifier hints in the CSR extension, so we might use that as a factor selector for optimal.
Oh, good to know. Yeah.
Everybody might have in mind.
And he said he's coming back in our eyes, so
Okay.
even afterwards you can have a discussion back in the same. I mean, a point on this, so I think I already mentioned like a testing PLS and testing CSR, and there is also this Verizon project for the verifier perspective, and combining all the three things. I'm interested in knowing the verification side. So because somehow our verification, I mean the formal verification side, not the verification of attestation. So from the formal verification side, we are kind of trying to cover the whole spectrum, and this is testing PLS, as I presented, testing CSR, and Verizon somehow, all these are parts of what we are trying to verify. So do you see any link towards Verizon, or do you, or kind of can you tell maybe what would be the additional challenges? Or do you think it's completely separate from Verizon? I'm just trying to get a high level idea of if we can extend it to maybe include Enarx, it means also, so you can also benefit from the formal verification, you will have formal specifications, verification which will improve your code as well.
That's a great question. I'm not prepared to know Verizon, so I'd have to look more at it to kind of come up with that. I definitely think there's a value in kind of having a, maybe not like one way of doing things, but, you know, a smaller set as opposed to a bunch of projects all doing their own thing. You know, and certainly Enarx doing its own thing kind of certainly makes for challenges with interoperability. That's certainly not ideal. But yeah, of course, there's always room for discussion, and whatever helps the project, quite frankly, is, you know, will make me happy.
Last week if you want about anything about Verizon.
Okay, cool. Yeah, we can have an offline conversation.
Correct, it's verified or Verizon, Verizon the carrier. Mobile.
No, it's,
So it's the CCC project.
Okay.
So this is the CCC project, which is the kind of the TV agnostic verification of any TV. So that's the kind
Sorry.
of the project. And I was, because I was presenting the verifier, which he has designed, so I was wondering what are the differences if we verify already that formally. So could we also include some additional challenges from him so that he benefits from the baseline that we verify, or is it completely somehow separate effort to do that? But I believe we can. So your you have this.
Yeah, thank you for the, we're just wondering, how does Enarx compare to wasn't I assume there's a probably does not, is not as often as.
we did some tests with that. If I remember correctly, I feel like it was negligible.
Oh,
I mean, so. I mean, I don't want to give any stating numbers because I don't remember. It was a while ago when we looked at that. Initially, we did have a abysmal performance, but then one of the guys on the team kind of realized that we weren't doing. We had a bad setting for how Enarx initializes WASM time, and we fixed it, and it was like double the performance from there. And I feel like there is a little bit of a performance loss from running in SGX or SMP. But overall, if I remember correctly, it was something at least we were happy with.
okay, so it runs both on top of wasn't.
So Enarx has WASM time inside.
Okay.
So Enarx itself has a component that runs on the host. And then there's a microkernel that sits inside of the TEE. And then on top of that is our wrapper around WASM time that does the communication with Steward. And then you have your WebAssembly binary.
Okay.